Hey everybody, today we'll do another math problem, and today we'll do another problem that is Laplace Transform, and hopefully the markers work better now because last time was a very horrible video. This is going to be a different problem, so I'm not going to be able to do the residue method. I'm going to do the method of partial fraction decomposition, and that's what we'll do it. We'll do this partial fraction decomposition. That's what we do. That method, right? So okay. So we have a problem right here. So we have this, right? So this is the S domain. We try to find what is called the inverse Laplace transform of that. That's what I'm trying to find, right? So now, we have this, right? And now, because this is technically what it was, is we had a Laplace of f of t, right? And this is just Laplace of, and this guy right here, this guy is technically the inverse of that. So basically, what I'm trying to say is this. So this is the Laplace of that. Okay, so that is the transform. Okay. So basically, we have this, which is this. We're trying to find the inverse going back to this. Okay, so let's get it done. So how we proceed in this? That's a good question, right? So the way that we do this, we simply write this guy like this. So the inverse Laplace of that, so f of, right? Or you can simply replace this guy with this guy right here, and you can put it like this. You can put like 2, okay, x squared plus 2s plus 1, right, over s, right, over s times s plus 2 times s plus 3. Okay, so now notice that I have this fraction here. So now my goal is to find A and B, and in this case I have 3 terms, A, B, and C, right? Okay, so let's get it done. So what I will do is the following. So let me erase that because I need some real estate here. So what I need to do, I need to put this guy in the left side, get rid of the denominator, and also write the other side in terms of A, B, and C. So let's do it. So s squared plus 2s plus 1 over s plus s plus 2, s times s plus 2 times s plus 3, right? And then equal to what? Equal to a times s plus 2 plus b times s plus 3 and plus c times over s, right? Now my goal right here in this case is to get rid of these denominators, right? The same thing. So I'm going to go ahead and write this on the top. So with different colors so you see it. So, okay, so let me just write this right here. So that guy is S on the top, S plus 2 times S plus 3, right? Now, right here, the same thing. So, okay, so right here, S plus S times S plus 2 times S plus 3 plus 3, right? Then, same thing over here. So S plus, okay, so S plus 2 times S plus 3, and then same thing over here, S plus 2 times S plus 3, and times S, right? Notice that now that I have this, I can actually get rid of this because this is my goal. I need to have a clean piece over here and also a cleaner piece over here. Even though this is going to be a mess, it's going to be a mess, I know that. But at least I get rid of these denominators, right? So I get rid of that and I get rid of this, right? And then in this one, what do I have at the top? So I have that one and I have this one, right? So I have those two cancel out, and then over here, what do I have? I have that one and I have that one, right? And over here, what do I have? Just that guy is out, right? And this guy is out, right? Now, next step is to write this in a clean manner, right? So we have S squared plus 2S plus 1 equals, right? So equal whatever is on the top, right? So what was on the top of this? That one and that one, right? Equal that one times this one, right? Okay, so A, right, is being multiplied by what? Being multiplied by S times S plus 3 plus B, right? B is multiplied by this guy, right? By this guy, right? That's B. So B is multiplied by S times S plus 2 and plus C, right? And C is multiplied by S plus 2 times S plus 3 because S was gone, right? So now my goal is to distribute this across, right? So now I get S squared plus 2S plus 1, and then right here I get what? Plus A, right? Inside I get what? S squared plus 3S, right? S squared plus 3S, right? Plus, so plus B, then I got it S squared plus 2S, and C is equal to C is going to be S squared plus that one times that one is S squared, this one times this one is 3S, right? And this one times this one is 2S plus 2S, and that one times that one is plus 6, right? Now let me S squared, let me clean this up, clean it up. So okay, distribute this, distribute that, and then combine this, right? So right here I will have 5S, right, plus 6, all right, plus this S squared, right? So S plus 2S plus 1 equal to AS squared plus 3AS, right? That times that times that, right? Plus B plus BS plus 2S. Okay? Plus BS squared, right? Plus BS squared plus 2BS plus, and then those two right here. So this is going to be equal to 5S, right? And then those two, right? So now plus C, right? CS squared plus, right? Plus 5CS, oops, plus 5CS plus 6C, right? Multiplying that guy times that guy, right? So now I got something. So now I can actually equate this. So I can actually look for the one that have a power, right? That have like exponential. So what I'm trying to do right here, I'm trying to map the coefficient of these guys, okay, with this. I want mapping this coefficient with this, right? So what do I have? I have an S squared, I have an A squared, I have a B squared, I have a C squared, right? Now, and then I have an S, I have an SA, I have BS, and I should have a CS. It's kind of, yeah, so, yeah, CS, okay. So, okay, so now all those guys are equal to that, right? And then the one is equal to this constant right here, okay? So with that being said, let me just get rid of this because I don't need this at the moment. I need some room right here, so let's get it done. So let me regroup this. So let me do it like S squared plus 2S plus 1, right? Equal to, I want to group these guys, right? So let me group it like this. So AS squared plus BS squared plus CS squared, right? And put parentheses around, and then plus. So this is gone, not gone, but just count for it, right? Now, what is next? Next is 2BS and CS and 3AS, right? So I got 3AS plus 2BS plus 5CS, right? Plus 6C. Okay. So now that I have that, I can actually get this piece with this. I can actually get that piece with this, and I can actually get that 6C with this one, right? Okay, so let's get it done. So the first one is S squared equal to AS squared plus BS squared plus CS squared, right? Now, okay, so now what I can do is factor out S squared on this side, and I guess I got S squared equal to A plus B plus C inside, right? And I divide this, right? Divided this by C on both sides, and I get 1 is equal to A plus B plus C. That's one equation, right? Now let me, so this is gone, this piece is gone, right? Now let me do the other one right here. So I got this piece of information that is necessary. Now let me do the other one. Let me do 2s equal to 3as plus 2bs 2bs plus 5cs, right? Again, right, divided 2s is equal to 3a plus 2b plus 5c, factoring out this s, so divided by s again, divided by s on all sides, and I get that 2 is equal to 3a plus 2b plus 5c, right? So that is another piece of information, right, that we need. Now, last but not least, we need to equate the constant, right? So now, that is a piece of cake, because that is 6c is equal to 1, right? So we have 3 equations, and which will have 3 unknowns, right? So we need to find those 3, right? So now, let's go back here and knock this out. So we have 3 equations. We have 1 equal to, let me just write it the other way, a plus b plus c equal to 1, and I have 2, I have 3a plus 2b plus 5c equals 2. And then I got it that c is equal to 6c is equal to 1, right? Now notice that you can actually be tempted to solve for 0 here and try to plug in c in this, but it doesn't work that way, because you have 3 variables still in this equation, so it's not going to help you anything. You can plug in c for this one, but it doesn't help. So what we need to do, we need to go back to the basics, right? And see what tools we can pull out from our mathematics, right? Basic mathematics. And we can see that we can use the process of elimination in this case, because we have 3 variables in these 2 equations, in this system of equations, that we need to get rid of one of them in order for this to help us out, right? So in order to do that, we need to get rid of any of these letters and then solve for 1, right? So in this case, let me try to get rid of b, right? Let me get rid of b. So how can I get rid of b? Notice that I have a 2b over here, right? I have a 3a over here. So I need to multiply by a negative 2 on the top in order to make this a negative 2, so I can actually get rid of, will be opposite signs, so this guy will cancel each other out. So let me do that. So let me multiply these equations by negative 2, right? And so it's a plus b plus c, right? And then is equal to 1, and that one also gets multiplied by negative 2. Okay, so when I multiply that across, I get what? I get negative 2a plus, negative 2b, negative 2c equal negative 2, right? Now I get this guy, right? Now I can actually add this 2, right? I can bring this over here and put it over here and say and it said 3a, right, plus 2b, right, plus 5c equal to 2. And look at that. Look at that. So now this a with this a add together, I got an a, right? And this guy is gone, right? So I don't have, I should put 0, but I don't put anything. Why? It doesn't really help any. This one and this one is plus 3c, and that guy is equal to 0. You might be saying, what the heck? What are you doing? You know, it's only equal 0. Well, yeah, I mean, it's math. I mean, if it makes sense, it will make sense eventually. You will taste the thing. That's the beautiful thing about this. When you're doing a process, you have a feeling, and you have a gut feeling that it's going to the right direction, and that's how mathematics is supposed to work. Okay, and that's why, yeah. So I don't want to get into the whole thing, but yeah. So, okay. So now we have this equation, right? We have a. So, and then we have this. Now notice that right now I can solve for this, right? Now I can say that 6c is equal to 1, right? And divided by 6 on both sides, and c is equal to 1/6, isn't it? Now I can get that 1/6, put it over here, and then I have an equation, right? And then I can solve for a, right? So a, right, plus, right, plus 3 times 1/6 is equal to 0, right? So this guy and this guy, right, again, now we're doing what? 5th grade math, right? We went to high school math, now we're doing 5th grade math, canceling numbers, right? So toolbox is being, you know, we pulling out tools out of the toolbox, right? So now what we do? So a plus, right? So that one and that one cancel out, and with that one with 2, right? I mean, I should not be doing this because this is differential equations, but just I don't want to get anybody confused, so I put a 2 over there, and that's 1, right? That guy canceled with 2 of those, and I got it 1/2 is equal to 0. Subtract this on the other side, I got it minus 1/2, and I got it a is equal to negative 1/2. Okay, negative 1/2. I got the first one. So now I got an A and I got a C. Now I need to find B. Right? So let me write it down right here. So C is equal to 1/6. B, A is equal to what? A is equal to negative 1/2. And B, we don't know yet, right? B, put the question mark, trying to find out right now. Okay. So, let's knock this out. Okay, so notice that right now I have these two equations. I can use any of these two equations. I can use any of those to find B. Doesn't matter. But why should I use the more complicated, right? Go with the easy one. Right? So A plus B plus C equal to 1, right? Now I have A and C, so I got negative 1/2, negative 1/2 plus 1/6 plus. Okay, so let me just do it in order. I don't want to confuse anybody again. So plus B, right? And I have a C, right? Plus 1/6 is equal to 1, right? Equal to that one. Now Notice that we can do this different way. We can take these two pieces, move to the other side, find a common denominator, and solve for b. Or we have a common denominator already. We can look at the common denominator across and cancel the common denominators out. Let's do that one. Okay. So what is the common denominator? 6, right? So 6. So now 6, multiply that, this by top and bottom by 3, right? And right here, this is 6, right? Multiply top and bottom by 6, that b right there, right? And then I don't have to multiply anything right here because I already have it. So 6 top and bottom by 6. Okay, so now I do my little things on the top, beautiful. So I get negative 3 on the top over 6, right? Over 6 plus b over plus 6b over 6, right? Plus 6b over 6 plus 1 over 6, right? Is equal to 6 over 6. Now I do this, so whoop, everything, all the 6 are gone now. Nice, isn't it? Now what I can do is just I have a regular linear equation. This one was linear too, but it had a fraction. This one doesn't have fractions. I use the common denominator to get rid of the whole thing, right, on both sides. So now what do I have? I have 3, negative 3 plus 6b plus 1 equal to 6, right? Equal to 6. Equal to 6, right? So add this 2, what do we get? Add this 2, what we get? We get negative 3, negative 2, right? So I got this one and this one, right? Added those two together. That gave me negative 2 plus 6b equal to 6. The other side, right? Move the 2 to the other side. Move the 2 to the other side. So what do I get? What do I get? Let me do it right here so it's clear. So negative 2 plus 6b equal to 6, right? So now plus 2 on both sides, plus 2 on both sides, and I get 6b equal to what? Is equal to 8 over 8, right? So it's 8 right now at the moment, just 8, right? So now I divide by 6 on both sides, right? Divide by 6, and I get that b is equal to 8 over 6, which is equal to 4/3, right? 4/3. Okay, now b is equal to 4/3 right here. 4/3. Okay. Now that I have all these values, I need to use the little table. Okay, so in the Laplace Transform, we have this little table that we use. So we have the values, right? So we need to use the little table. So we have a little table so these are the values right now, right? So all this, okay, so these are the coefficients, right? So now what is okay, so I need, remember that I had A and I had a B and I have a C, so I had this. So A was S plus 2 and B was S plus 3 plus C was S, just regular S. Now from the tables, now remember that I have this number right now. from the table we have this following, right? So from the table we have they say in the other book says that 1 over s is equal to u of t, right? In this case, and another one says that s 1 over s is equal to 1, right? 1 over s is equal to 1. Okay, and this has to do with the delta function, which I'm not gonna get into it right now. So unit step, the unit step function, unit step, that's the U stand for unit step, sorry. Okay. So the unit step function is equal to 1 over s equal to 1, right? Which can be represented like that in the table, the unit step. Now, so we have a unit step function, right? And that unit step function is belong to whatever number it look like. What is it? It's this, right? So that's why they use the table, and they have as, so from the table we can determine that the Laplace transform of, okay, so the Laplace transform of the Laplace transform of u of t, right, is equal to 1 over s, right? Now 1 over s is so 1 over s, right? So what is representing the 1 over s? Like I said, it's representing this guy, which is that guy, right? If you factor out, think about this, you factor out 1 over s out. So this is 1, you factor it out, you will get this, multiplied by c, right? So now, what we do, right, in this case? So in this case, simply what we do is the following. So we have an s, on the top we have a 1/6, right? So we do like this. So 1/6 over s. See? 1/6 over s, that 1/6 comes out, and the inverse of the Laplace transform of that now, the inverse of the Laplace transform of that, the inverse of that u of t, alright, of, so in this case we had f of s of that, right? So the inverse of that now is equal to what? Bring that to the front is equal to 1 over 6. 1 over 6 times s. Yes, 1 over 6 times s. Oh, yeah. So 1 over 6x, like that. And this is an s. It looks like 65, but it's okay. So 1 over s. Right? So it's 1 over 6s. That's one of the pieces, right? So that is for this one. Now we need to do A and need to do B. Now according to the table, according to that table, according to this table, so if I look for the A and B, if I look for the A and B, according to this, it looked like A plus 2 plus a. Two plus a so the Laplace transform of the inverse of Laplace transform of, right? So e to the at, right? So e to the negative at, the inverse Laplace of that, right, is equal to 1 over a plus something, a plus s, right? S plus a, or s plus a, right? When a is equal to a constant, right? So in this case, what was my a? In this case, right? Let's say, for example, I'm doing a right here. So a was 2, right? So now the inverse Laplace transform, now that a is equal, is going to be e to the negative t. Why? Why? Because this was positive. I just replaced the a with a 2, and that becomes that, right? Now think about that. Think about for a moment. So now okay, so now that is, but remember that was that two was over 2, right? With well, I mean for 2 that was a negative, right? So that negative, now basically, okay, so let me, if I do this step by step, right? And this is the thing, because we're trying to use the table, to map this out. So in that case, because okay, so let me just do it right here. So I know that it's going to be negative 1/2 on top, right? Right? Negative 1/2. And that negative 1/2 is multiplying this guy, multiplying that 1 over a over s plus a, right? But a was 2, right? And that a gets transformed according to this. That a goes to the top, right? So this, right? So now I gotta replace whatever the number of a was. In this case, a was 2. So now, all I gotta do right here is replace that a with a 2t. Okay, so now that take care this guy, and that guy is taken care. And now I need to do this. Same thing, right? So now I have that. Now I need to do this. So what is b? So b is negative 3/4, right? So 3/4 is being multiplied by 1 over s plus a. Again, similar. And then that gets it's to exponential e to the t, negative. Now, notice that this guy technically is supposed to be on the top here. 4 4/3. Yeah, 4/3. Now, that guy gets put into the front because that's the rule that we use. And then we have 4/3, right? And then I got E, and what is, okay, so what is this? This is 2, right? So this is This is 3 actually. 3. So now this is negative 3, negative 3t, right? So now this can be moved to the bottom, right? Doesn't matter, right? This can go underneath here, and this can go just on the top, right? So the bottom line is the answer for that is, if you put the pieces together, if we put these pieces together, right? So we have 4/3 e to the negative 3t minus, actually it's, first, let me just do it by order. So negative u of 6s, negative u of t. Yep. Negative u 6/t, right? Because that was the first one we found, a, right? A. So actually no, that's c. That's c. Yep, that's c. Okay, so a is a half. So this was the C, this was the A. Okay, so basically it's 1/2 negative e to the 2t negative, right? Negative 2t, right? And then I have b, right? I got plus 4/3 e to the negative 3t plus, according to the table, that 1/6 is positive, so it's 1/6 u of t, right? And that should be the answer. Now you can factor the stuff out over here if you want to, but will that really help? Right, so yeah, or you can write this at the reverse time. It doesn't matter. Once you have this, you can do this at reverse. You can have it like, because technically, what they try to do, they try to put this in order. Like this one has less, this is starting like, this is a unit step function, and then the rest, right? So, yeah, so you can write it like this too. You can write it like this. So f of t, which is the function now, is 1/6 u of t, and then negative 1/2, I think that's what they have. Yeah, negative 1/2. So e of 2t over 2, right? Plus 4. Plus 4e to the 3t over 3. And that's how. Okay, so that's it. See, it takes a little longer to follow the table.